In this video, we are going to learn about the systems of linear equations, which plays a central part of linear algebra. So what is a linear algebra? It will be providing some tools in order to solve the systems of linear equations. So these systems of linear equations, it will be representing some problem. Okay, so many problems, it can be represented or formulated based on the systems of linear equations, and linear algebra, it will be providing us with the tools in order to solve those equations. So algebra, it is an approach to construct a set of objects and a set of rules in order to manipulate these objects. And linear algebra, it is the study of vectors and certain rules to manipulate the vectors. So vectors, they are considered as the special objects that can be added together and multiplied by scalars to produce another object of the same kind. So vectors are those objects which will be satisfying these two properties, like they can be added together and also they can be multiplied by scalars to produce any other object of the same kind. So many vectors that you have learned earlier are like geometric vectors. So you might be aware of the geometric vectors, like it is represented like this. Okay. Vector A will be one vector and vector B another vector. So when these two vectors, they are summed, then you will be getting another one vector, that is vector C. Okay, for vector A and vector B summed up to get another vector C. Also, if any constant value, if it is multiplied, that is if C belongs to some real world entity R, then if I multiply this C vector with some scalar quantity, that is lambda, so lambda multiplied with the scalar quantity, then also it will be belonging to some object which will be an element of this real world entity, real world R. Okay, real vector space. So this is like geometric vectors. So this R, usually it will be denoted like this, that is like this textbook and everything, it will be denoted like this. Two lines will be drawn like this. Okay, in order to signify the real world space. Okay, real numbers it will be denoting. So vectors can be anything. Two properties that it will be satisfying is like it should be added. Vectors can be added together and to produce any other object of similar kind, and also any scalars can be multiplied to this vector to produce another object. Linear algebra, it plays an important role in machine learning as well as in general mathematics. So why we are concentrating on it? Because we are learning some concepts related to the machine learning, and in future also while performing vector calculus or while learning about dimensionality reduction or linear regression problems, linear regression, dimension, this comes under the machine learning applications. So in all those tasks also we make use of this linear algebra. Okay, so systems of linear equations, it plays a vital role in the linear algebra, and linear algebra, it helps in giving us with the tools in order to solve the systems of linear equations. So we can start with the notations and with the help of an example. So linear algebra, a company produces products n1 to nn, n suffix n, okay, for which resources r1 to rm are required in order to produce this n1 to n products. So to produce a unit product Nj, to produce any product Nj, Aij units of resource Ri is required, where this I, it denotes the 1 to m, that represents the resources. Okay, and J unit in this Aij, J represents the products ranging from 1 to n. So Aij means this I and j, it will be denoted as a suffix Aij. Aij units of resource Ri are required, where I will be 1 to m and j will be 1 to n. The objective, what is the objective, is like an optimal production plan, that is a plan of how many xj of product nj should be produced if a total of bi units of resource Ri are available and no resources are left over. So we need to find a solution. So the solution is like how many units of xj, that is how many units of x values is required in order to produce any product nj, so that it will be making use of bi units of any resource Ri. So in order to understand this statement, we need to learn about some equations like this. Okay, so here, as I have said, here A11 means what? A11, Aij means units of resource Ri are needed in order to produce any unit of product Nj. Similarly, A11 means some product N1 will be produced using how many units of resources? A11 units of resource R1. Okay, A11 units of R1 resource is required to produce any unit of product Nj. So for that, B1 available resources are there. B1 is the available number of resources. So summing up of all the resources in order to produce the products N1 to Nn, which will be varied like x1, the different products will be varied based on these x1, x2, etc. up to xn. Okay, summing up all the values, you will be getting the number of resources, that is B1, that is B1, that is the available number of resources, and no more remains will be there. Okay, from this equation you need to find an optimal solution of x1, x2, etc. up to xn. So you need to compute the value of x1 to xn so that a product can be produced ranging from A11 to A1n, or that tuple you will be able to formulate for the given set of equations. Okay, so this x1, x2, etc. up to xn, it will be representing the number of units of products that will be produced, and A11, etc. up to A1n, it represents the number of units of resource. I repeat, x1 to xn, it indicates the number of products that will be produced, and A11, etc. up to A1n, it indicates the units of resource that is used in order to produce a product. Similarly, we will be having some n systems of equations. Linear equations will be there. From the given n system of linear equations, you need to find out a solution for this x1 to xn, which belongs to the real number Rn. And this n corresponds to the number of x variables. So an optimal production plan, it will be a tuple ranging from x1 to xn, which belongs to Rn, should satisfy the following system of equation, where aij is an element of R and bi also it is an element of R. Now these given some 3 examples that comes under the systems of linear equations. So consider the first example. So in this case we need to find out the optimal solution. So optimal solution is like you need to find out the value for x1, x2 and x3. Okay, from the given set of equations you need to solve to get the value for x1, x2 and x3. So as we have learned earlier, you need to solve these equations. So first you can perform 1 plus 2. 1 plus 2. So when you do 1 plus 2, you will be getting 2x1 plus 3x3, 3x3, which is equal to 5. So in this case what happens, this is a new equation generated after solving equation 1 and 2. So when you are comparing the equation 3 and equation 4, the left hand side is same, isn't it? 2x1 plus 3x3 is equal to 5 you have generated, and the given equation it is given as 2x1 plus 3x3 is equal to 1. So there occurred a mismatch, hence from this equation you won't be able to generate any solution. So no solution will be generated because the generated equation, it is somewhat different from that of the given equation. Now consider the second set of equations, set of linear equations. In order to solve that equation, what do you need to do? You need to first solve, that is, here you can just solve it like substituting the value of 3 in 1. Substituting the value of 3 in 1, you will be getting as x1 plus x2 plus x3 is equal to 2. So x1 plus 2 is equal to 3, and x1 will be equal to 1. Okay, so this is one equation, and then so x1 value you got. Now next is like you need to get the value for x2 and x3. So for that subtract 1 and 2. Subtract the equations 1 and 2. So what you will be getting? Okay, no need to subtract, you can just add the equations. We can see, but x1 minus x1 0, x2 minus x2, that is 2. Okay, you can just add the equations x1 1 plus 2. So 2x1 plus x2 gets cancelled, 3x3 will be equal to 5. And so substituting the value of x1, you will be able to get the value of x3 as 5 minus 2 by 3. 5 minus 2 by 3, which is equal to 1. Okay. Now next is like you got the value for x1 and x2, x3. Now you need to find the value of x2. So what is the value of x2? You can substitute the value of x3 in this equation. You will be getting the value as x2 is equal to 2 minus 1, which is equal to 1. So the tuple formed is 1, 1,